Okay, let's do a review of viruses. Viruses are a non-living parasite. That means they need to live off of something else. They're not made of cells, so they're acellular. They have no metabolism. They don't take in anything or use energy. They rely on the host cell for energy and enzymes. They use the host, energy, and enzymes in order to replicate. It may seem like they're living because they do have DNA and RNA and they do make more of themselves, but in doing so, they're using the host cell's energy and enzymes, which is why you get sick when you've been invaded by a virus. It's made of that protein coat or capsid, a nucleic acid core, whether that's DNA or RNA, a tail sheath, and tail fibers. And it's those fibers which determine what the virus can attach to. Bacteriophages are a virus that attack bacteria and kill bacteria. The structure of a virus, again, it either has DNA and RNA. Larger viruses are going to have an envelope around them. It just gives them a little bit of an extra protection, but they still have those tail fibers and they still have that DNA there that they use to make more of themselves. So they are host specific. The attachment site from the virus and the receptor site from the host need to fit together like a lock and a key, and they kind of looks like a spaceship docking itself. And like I mentioned in the other video, there's a little caption of this coming up. The 5 main steps that viruses go through in order to get inside of an organism and infect it. First, it has to attach itself, and those tail fibers of the virus and the receptor sites of the host have to get together and fit together like lock and a key. Then the DNA and RNA has to get into the cell. Then the DNA and RNA has to be replicated along with more capsids, and that's biosynthesis. The DNA and RNA and the capsids come together, that's maturation, it just matured, and then it can release and go and affect more cells. The virus can get inside of you in one of 2 ways. Once it fits together like the lock and the key, the receptor sites and attachment sites fit together, it can get inside of you one of 2 ways. The first way is where the virus capsid stays on the outside and just its DNA goes on the inside. Now remember, the DNA is used to make more of the virus. And the other way is when the host cell engulfs the virus, which is known as endocytosis, as you can see in this diagram. There are 2 different phases or cycles that a virus can go through, the lytic cycle or the lysogenic cycle. And you have another handout that describes this more in detail. The lytic cycle is that attachment, penetration, biosynthesis, maturation, release, and it's releasing thousands of viruses to go attack your cells. And remember, once your immune system starts catching up to this, the virus is attacking your cells, then you will start to get better. But until then, you are sick. The lysogenic cycle works in a different way, but in the end, the lytic cycle does kick in. That lytic cycle, like I mentioned, is just that attachment, penetration, biosynthesis, maturation, release. And again, you have access to this PowerPoint, so you can look at these as many times as you want to. Like I mentioned earlier, the lysogenic cycle is a little different. The viral DNA first, once it's penetrated, the viral DNA mixes in with the host DNA. At that time, it's called a provirus. the provirus DNA is copied. Every time that cell makes more of itself, that virus is making more of itself. So year after year after year, that one cell is making more of itself, those two new cells making more, and so forth. Every time that happens, that virus is being replicated along with the host cell. So this virus actually remains dormant for years until some kind of trigger activates it. So all viruses will then enter that lytic cycle simultaneously. So until that trigger happens, that virus is dormant. Once the trigger happens, then that lytic cycle can start to occur. So you already had attachment, you already had penetration. At that time, it stays dormant. And it's making many viruses over and over and over again. And then the trigger takes place, and then you have biosynthesis, maturation, and release. And it can be thousands to thousands upon thousands of viruses being released at the same time. All those host cells then are killed at once. So with the lysogenic cycle, the virus attaches to the host. Then you have the attachment, you have penetration. And then at that point, the provirus is formed when the viral DNA becomes part of the host DNA, and then that host DNA cell will just go through replication as it normally would. Eventually, some trigger causes the virus to enter a lytic phase, releasing them and killing the host cell. So this has happened to hundreds of cells, so hundreds to thousands of cells. So you'd have hundreds to thousands of viruses being released at once. And again, cold sores, genital herpes. And cold sores are actually a herpes virus. Genital herpes is also obviously herpes virus. One is herpes simplex A, the other one's like herpes simplex B. Hepatitis B, HIV is the virus that causes the disease known as AIDS. HIV is the name of the virus. Chickenpox, and actually with all viruses, those viruses stay in your body. Your body doesn't ever really get rid of that virus. With chickenpox, I mentioned this in the other video, that virus is in your body, and if something triggers that virus all over again, you will then later in life, you could get shingles. HIV, you get one little virus in your cell, and it hangs out in that cell, and when that cell replicates thousands and thousands and thousands of times, you now have thousands and thousands and thousands of HIV. A trigger comes along, all of those HIV viruses are triggered to go through biosynthesis, maturation, and then release. And what they're affecting are the white blood cells, so you have the killing off of thousands of white blood cells, which means your immune system has been compromised. So viruses enter and replicated by cells. Eventually all the white blood cells are infected. When triggered, the provirus will kill all the white blood cells at once. At that point, that's when the person is considered to have AIDS. And their immune system doesn't work right, and they usually do not die from HIV itself. They die from many kinds of cancers. A lot of them get tuberculosis. Their immune system just doesn't work. And you may not know it, but your body protects itself from cancer on a daily basis. Your immune system is going out and hunting down cancer cells which don't belong and get rid of them. So when an immune system has been compromised, a lot of times people will get cancer. AIDS, HIV technically, is what is known as a retroviruses. Retros work backwards. Think of the word retro, it means backwards. Retros have RNA, and they have an enzyme called reverse transcriptase. So as we learned earlier, normally you go from DNA to RNA. Retroviruses start out as RNA, and then they go to DNA, and then can go back into RNA. So it works in a reverse manner, reverse or backwards retroviruses. Viral drugs, we are just now coming out with a few of them. But again, as you know from the diagrams, the virus is inside of you. It's inside and affecting your cells. It is very hard to find some drug that's going to attack the virus, but not attack the host cell. If you attack the host cell, you're killing the host cell, and that's what the virus is doing anyway. So only have we recently found medicine that will attack the virus without affecting the host cell. Because what most medicines do is attack enzymes. Well, viruses don't have enzymes. They use our enzymes. So in essence, if we were to try to take a medicine to kill the virus, we'd be killing our own cells.